In this video, we'll go through setting up the FLOEFD project. First, make sure you launched FLOEFD for Creo using the appropriate executable. And that's found under your Start, Apps, and scroll down to Simcenter FLOEFD for Creo. This will launch your Creo software with the FLOEFD embedded inside here. Now also note, you must open an assembly with at least one part in Creo in order for FLOEFD to be active here. So to start, first I like to unselect the Creo displays here to make the geometry a little bit cleaner. And then we have two options to start the project of FLOEFD. In the wizard, you'll be guided through which physics you want to use, direction of gravity, your ambient condition, default materials and fluids, and so on, which we'll go through here. The second option is to select New, which allows you to select a predefined template. For example, once we go through the wizard, we go through the mesh settings, and even post-processing, you can later save this template by going to Project, Create Template, and in another model, you can just load that template and you'll have all your features and boundary conditions and everything set, ready to go as you set it before. Okay, so in this, we have an assembly here with the enclosure and the two gap pads. We will import the PCB later on through EDA Bridge and then align the gap pads to that PCB. Alright, but for now, let's go through the wizard. Here you can name the project, hit next. You can select which unit system you want to use. You can also modify some of these predefined ones, customize it, and save it for future use. So for example, typically for electronics, I like to work in millimeters and Celsius. For volume flow rate, I like to use CFM. Then we hit next. And here you can choose which physics you want in your simulation. So for this one, we will do fluid flow and conduction. Notice also we have structural, electromagnetics, and free surface. So these are extra physics you have in FLOEFD that were not available in Flowtherm XT. So for here, we'll also select radiation. We can change the environment temperature to be, let's say, 30 degrees Celsius. We want to turn on gravity as well. And we can see the direction of the vector. Let's change that to X direction. So I'll just copy this, put that to 0, and paste it here. Okay. For analysis type, this is external, meaning we'll have fluid flow outside of this enclosure as well as inside. For geometry recognition, there is an extra option here that's not available in XC, which is called Mesh Boolean. And that is an extremely powerful geometry recognition process that allows you to work with very complex models and also unclean geometry. So for example, if you had CAD geometry that was translated from one CAD tool to another, some of the geometry is a little bit broken, Mesh Boolean can handle that fantastically and process that geometry a lot more efficient and faster than the previous options. So if you do have complex geometry, dirty geometry, or just many parts, definitely try and use Mesh Boolean operations. Alright, we'll hit next. Here we can select the fluid. So you can either double click or hit add here. Next. Here we'll select the default material. So let's just pick a random one here. Let's do metal aluminum. Here we can select the default wall radiative surface. So let's select one. And this opens up your engineering database. And I'll go over engineering database in more detail later on. But essentially this is where you can store information about things like material properties. In this case, we see radiative surfaces filtered here, so that's all we see. There's other things like true resistor component information and so on. All right, so we can go to predefined, and this comes with your FLOEFD install. So let's just select one here. We'll do aluminum. Under item properties, we can see the emissivity coefficient, 0.27 here. So we can select that. And then, of course, you can modify it. So, for example, you can create a new one under user defined. You can also copy it, go to user defined, and paste it here. You can name it something else and then change your properties here. Okay? But for us, let's just choose that and hit OK. And now all the objects in our simulation will be aluminum for our radiative surfaces. Later on, you can select different surfaces to have different radiative surface properties as well. And lastly, here we have our initial and ambient conditions. So here we can change the temperatures, for example, and then for solid temperatures as well here, let's say 30 degrees Celsius, and then we'll hit finish. Okay, so our project was created. We can see the project is here, and it created a computational domain. So at this point, we can go down the tree here and change the features for selecting certain materials on objects, boundary conditions, mesh settings, and so on.